And here you're gonna see that plot, okay? If you do Cocoa style, average precision, then this is where you have your Cocoa. This is, as we just saw, it's very to the left, it's very fast, but then it doesn't seem to be as accurate when it comes to Cocoa style average precision. But then if you go to Pascal VOC, which is Cocoa mean average precision with the intersection over union being 50, then you start to see some advantages for YOLO version 3. So I encourage you to read this paper. It's actually another paper. It's mostly a report by a smart student in deep learning, and that's going to give you a feel of how much trouble students of deep learning go through to come up with these results, okay? So I highly encourage you to read that paper. It's another paper. Unlike what we covered so far, that one is another paper, but it's a good idea to read it, and you're going to have a lot of fun. So there's a debate with nowadays of what is the correct metric for measuring the performance of object detectors. And I know that Surush was very interested in seeing darknet. This is darknet 53. It's at least one of those versions. So that's your darknet. You're going to train it on ImageNet, and then part of it you're going to use for transfer learning. What changes did they make? You're going to have your method predict 3 boxes at 3 different scales, and these are 3 different scales. It's very similar to what we covered in the previous paper for feature pyramid networks. So you're going to have 3 different feature maps, and each one is going to predict 3 boxes. In the end, you're going to have each one you're going to divide by n bins. Each bin is going to predict 3 boxes, and then you're going to have 4 coordinates for your bounding box offsets. You're going to have 1 objectness prediction and AD class prediction. And there is also another minor change. Rather than using a softmax, we know that softmax is going to create competition between classes. They said you don't need to use that, and there is no mathematical reason for it. It's just experience and going through the trouble of training these networks thousands of times. And it says rather than using softmax, you can use a binary cross entropy loss. So it's going to be a sigmoid. And this is in terms of performance. If you go with Cocoa style average precision, then yes, the previous paper RetinaNet is the state of the art at that time, 2008. Okay, any questions before I move to the next topic?
This the capital N there, is that what is that number?
If you remember for YOLO, you divide your image into bins. This N is the same as S from YOLO paper, S by S. It's the number of bins that you have.
Cool.
It's like here. Now you have N by N rather than S by S. Any other questions? I think I'm gonna close the chapter of object detectors, and I think you have enough. You have a strong background now dealing with images. Let it be classification, let it be object detection, let it be segmentation, let it be super resolution. So I think with this background, you're gonna be very comfortable following the state of the art from this point on. Let's change the type of the data that we want to work with for the rest of the course. So far it was images, then we are gonna go into videos, and then we are gonna go into point clouds. So we're gonna change the type of data that we're gonna work with.